Hi, Algebra 1 students. These notes are on simple and compound interest. And interest is a word you may have heard before. This is an application of mathematics, and interest is typically looked at when it comes to banking. So a bank does two things. One thing a bank does is it loans out money. So that means you could borrow money from a bank. But when you pay back that money, you're going to have to pay back interest on the amount of money that the bank loaned you. So you end up paying the bank back more money and the bank earns money. So loans are one way that you think about interest. And then the other way is that the other purpose of a bank is that you can put your money in it and have a bank account, right? So that's for like savings purposes. And the bank wants you to put money in at the bank so it can loan that money to other people. So the idea is if you put your money in the bank, you earn interest on that money. You earn a percentage gain each year. So the bank is kind of like adding to your savings. Now, there's two ways that interest can be calculated, and there's two different models. And one is simple interest, one is called compound interest. Simple interest is interest calculated once per year on the original amount that was borrowed or invested. Okay? So interest is calculated once per year on the original borrowed, or it could be that you invested the money, right? There are two options. Invested amount of money. And the key difference between simple and compound is going to be that simple, the interest is calculated on your original amount. But compound, we're going to say the interest is calculated once per period, and the period of time could vary. So it could be that it's still yearly, or it could be that it's monthly. So once per period on the current amount. Of money borrowed or invested. So that current amount is the key difference. Original amount versus current amount. And it's going to mean something different when we go to try to think about writing a formula in each situation. So if we look at example 1, it's an example of simple interest. We have Kyra has been babysitting since the 6th grade. She has saved $1,000 and wants to open a bank account so that she will earn interest on her savings. Simple Bank pays simple interest at a rate of 10%. How much money will Kyra have after 1 year, after 2 years, if she does not add money to her account? After 5 years? Okay. So that's kind of like, we have a bunch of questions to ask, and we're going to try to like establish what the pattern is here. So we know that she's starting with $1,000 in her bank, and we can kind of think about this as when time is 0. And this is like our initial amount. So no time has gone by. Then a year passes. Okay, so at the end of that year, Kyra will earn 10% of her original amount invested. So her original amount was the $1,000. So it's going to be 10% of $1,000, which would be, we could think of it as 1,000 times 0.1. So that's $100. So we're going to add 100 to 1,000, and we get $1,100 after a year. So that would be t equals 1. Now, if another year passes, the interest is still calculated on the original $1,000. So it's still going to be 10% of 1,000. So I'm adding that same $100 here to get the amount after 2 years. So after 2 years, we would have $1,200. So we can sort of see that this would be repeated addition here of plus the 100. And it's kind of becomes even more clear how we could kind of model this if we use the table of values and we thought about our input as t time and our output as a of t, an amount of money in her bank account. So after 0 years, so this is time in years, right? After 0 years, we have $1,000. 1 year, 1,100. 2 years, 1,200. We can imagine 3 years would be 1,300, and we could keep going from there. But we know we have this plus 100 pattern. So this kind of allows us to create a formula for A of t. It should be clear by now that this would be a linear pattern, right? Which means we need to think about y equals mx plus b. So here we have our A of t instead of y. I'm going to kind of put this in like a little bubble. A of t equals, m is our slope in mx plus b, so our slope here is our rate of change. So our constant rate of change is that plus 100 repeated addition. So it's going to be 100 times t number of years. So instead of x, we have a t, plus the initial amount when t equals 0, how much money is in the bank account? $1,000. So I'm going to say 100t plus 1,000. And this would allow me then, if I evaluated A of 5, I could calculate how much money we should have after 5 years. And we get 100 times 5 is 500, so we get, after 5 years, $1,500. So now there is a you try problem for you to try. So it says Raul needs $200 to start a new snow cone stand for this hot summer. He borrows the amount of money from a bank that charges 4% simple interest per year. How much money will he owe if he waits a year to pay back the loan, 2 years, 3 years, 4 years, 5 years? So this process here will work exactly the same as the previous example, except the only difference in the situation is that instead of putting money into savings and earning that interest into your savings account, now it's kind of like a negative thing in that you borrowed money. Raul borrowed $200, and now he's going to have to owe money back. So the interest being calculated as being, the calculation gives us what amount he owes. And we should be able to, in part B, write a formula. You can write a kind of A of t equals formula, but you want to kind of keep in mind that y equals mx plus b format. So now let's look at an example that is compound interest. And this is going to be a little bit more complex as to how to think about the formula, because it's not going to be linear here. But it says Jack has $500 to invest. The bank offers an interest rate of 6% compounded annually. So annually means yearly, which means so we're going to get an interest rate of 6% every year. How much money will Jack have after 1 year, 2 years, 5 years, 10 years? So here we can again kind of draw a little diagram where if we think about the initial amount as being 500, that would be when time is 0. A year goes by, so now we have time equal to 1. And the interest is 6% of the current amount. So that means 6% of the previous year, which was 500. So we would do 6% of 500. If you do 0.06 times 500, you get 30. That's telling you to add 30 to 500, and you get 530 after 1 year. So that would mean after 1 year, he would owe back $530, even though he only got loaned out $500. Well, suppose another year goes by, Now, the way this year will not just be adding 30 to the previous amount, because compound interest says you take 6% of, or you take the interest percentage of the current amount in the bank account, or the current amount that you owe. So that would be 6% of the 530. And that would end up being 31.8 if you do 530 times 0.06. And that means that the new amount of money that he would owe back after 2 years would be 561.8, or 80 cents. And we could keep kind of building up like this, but I'd like to kind of try to look at the structure of the calculations we're doing here, and that's going to kind of help us think about how to write a formula. So the idea would be that if we think about what we're doing when we take a percentage, so after year 1, we're taking the 500 that we started with, and we're adding to that 6% of 500. So I'm doing 500 times 0.06. Now, I'm going to think about a way I could rewrite this, and what I notice here is I have 2 terms of this expression, and the 2 terms would be this 500 and then plus, remember, addition or subtraction separates terms, so I have the plus sign, and then I have a second term, which is 500 times 0.06. And within those 2 terms, they have something in common. They both have a 500. So I could actually use reverse distributive property here and take out the 500 and write it out front. And then what would be left? Well, from the first term, nothing is really left. I took out the entire 500, so what I want to put in its place is a 1, because 1 times 500 would give me back 500 if I were to distribute this 500 back in. And then plus, well, what's left over from the 500 times 0.06? Just the 0.06. So now if I combine these like terms inside the parentheses, I would get 500 times 1.06. Now this actually makes it slightly easier for me to do my calculation, because it means that to get from the year 500 to the 530, all I need to do is multiply 500 by 1.06 now, and I'll get exactly 530. Well, if I think about year 2, well, year 2 is taking that 530, right? Which is really 500 times 1.06, and multiplying it again by 1.06. And I'm going to kind of like show this in a few more steps by thinking, okay, well, what did we do? We really did 530 plus 530 times 0.06. That's that 6% of 530, and that's what we got with that 31.8. Now, again, I could rewrite this using distributive property and say this is the same as 530 times 1.06. But really, remember, as I just mentioned, this 530 is the same as the 500 times 1.06. So if I replace 530 in this expression with 500 times 1.06, I would then have 500 times 1.06 times 1.06 again, where like one of those comes from up here, what I'm underlining, and the other one comes from over here. Okay, so we're going to start to see this same pattern repeat itself for year 3. So the year 2 amount, by the way, was that 561.8. So if you were to multiply 500 times 1.06 times 1.06 again, you would get that 561.8. So again here, the year 3 then is taking 561.8 and adding to it 6% of it. Right? And again, with my reverse distributive property, I can take out the 561.8 and write this as 1.06 which really means this long repeated addition of 500 times 1.06 times 1.06 again times 1.06 again. And these three 1.06s, that was a mistake, are coming from the two of them come from the previous year, right? There was two up here. And so this 500 times all of that gets wrapped into the 561. And then there's this extra one. So we start to see this pattern of repeated multiplication. And if you set it up in a table, you might be easier to kind of tell. But we start in year 0 with 500. We multiply that by 1.06 to get the next year, which is the 530. We multiply that by 1.06 to get year 2, which is the 561.8, right? So we have this repeated multiplication, which really means this is going to be an exponential formula. So the idea of that would be, I'm going to have A of t, or the amount of money that he owes back, would be the initial amount of the 500 times 1.06 raised to the t power, right? Because after 1 year, we're multiplying by the 1.06 once. After 2 years, multiplying by it twice, and it keeps going from there. So given this formula, the last thing I'd like you guys to do with these notes is calculate what would A of 5 equal, and then what would A of 10 equal, because that would give us how much money he would owe back after 5 years and then after 10 years. And if this is still a little bit unfamiliar to you, we are definitely going to be practicing in class.